probably have seen an orange coloring covering metal objects like seen here on this large iron step. This orange substance is referred to as rust, and it represents a reaction that occurs between the metal iron, as seen here, and the oxygen found in the air. The combining of iron and oxygen is an example of a synthesis reaction. A synthesis reaction occurs when two or more simple substances combine to form a more complex substance. The chemical equation for rusting is the following. Iron, symbolized by Fe, reacts with oxygen to form FeO2, or iron oxide. This rotting tree log is undergoing decomposition, which is the process of breaking down. This process occurs in many chemical reactions in which a substance is broken into simpler substances. This is called a decomposition reaction. In a decomposition reaction, a substance breaks down or decomposes into two or more simpler substances, the opposite of a synthesis reaction. When electricity is applied to water, it may undergo a decomposition reaction, producing bubbles of oxygen and hydrogen gas. In some reactions, it is possible for an element actually to replace an element in another compound. Here, the copper in the blue solution replaced the iron coating on the nail. In a single replacement reaction, atoms of one element replace atoms of another element in a compound. For example, when copper wire is placed into a solution of silver nitrate, over time the copper gradually replaces the silver in the solution, forming a blue copper nitrate solution. This single replacement reaction is represented by the equation Cu plus AgNO2 yields CuNO2 plus Ag. In other reactions, it is possible for atoms in two compounds to replace each other. A double replacement reaction involves atoms in two different compounds trading places with each other. Here, silver nitrate is mixed with potassium chloride, causing the potassium and silver ions to trade places with each other, resulting in a double replacement to form two new compounds. In this equation, notice how the silver, Ag, bonds to the Cl, and the potassium, K, bonds to the NO3.